So we want to look at AC circuit. AC circuit, known as the alternating current circuit. Now, what is an AC circuit? An AC circuit is a circuit through which an alternating current flows. And an alternating current is a current that changes direction periodically. So when you have a current that changes direction periodically, you have our alternating current. And when you plot a graph of the current, have a graph and plot a graph of the current or the voltage or current on the vertical against time on the horizontal, you have a sinusoidal curve. So the current changes periodically from positive value to negative value, so it oscillates along this form. So such a current that changes direction periodically is known as alternating current. The graph of V, or the voltage or the current, is plotted against time. You have what we call the sinusoidal function. Sinusoidal function or waveform. And we can measure alternating current using the moving iron ammeter. The moving iron ammeter. We can also use the hot wire ammeter. And we can also use the third one, which is the moving coil galvanometer. This moving coil galvanometer, a rectifier must be attached to it. So with attached rectifier, so basically these are the three instruments that we use to measure alternating current: the moving iron ammeter, hot wire ammeter, and moving coil galvanometer with attached rectifier. So what is the function of this rectifier? The rectifier is a device that will convert the AC to DC. So rectifier converts AC to DC. So the rectifier will convert the alternating current to direct current. Please, before we continue, I would like you to subscribe, like, comment, and also share this video. Please, I want you to subscribe, like, comment, and also share this video in order to make us grow. Thank you. Alternating current is produced by an alternating voltage source. And since this is a relationship given by V equal to V maximum sine Wt, where your V is your instantaneous voltage. V naught, that is V maximum, is your maximum voltage in the circle. Here is your maximum voltage you have obtained from this circle. Our W or Wt is our phase angle. Wt is our phase angle. And what is the phase angle? The phase W is equal to 2 pi f. It's equal to 2 pi f. So let's see some very special equation in AC circuit. We have a relationship V equal to V naught sine phase angle, where your phase angle, the phase angle is WT. And when we say phase angle, it is the angle by which the current leads or lags the voltage in an AC circuit. So here we can say V is equal to V maximum sine WT, where our W is equal to 2 pi F. So when you bring that into that equation, you have V is equal to the peak voltage sine 2 pi Ft. So note this equation. These are motion. So that will be, the current also will be, current is equal to your peak current sine 2 pi Ft. So all these equations are very, very important in AC circuit. So students should familiarize themselves with all these equations so that they're able to solve some calculation problem under alternating current circuit. Please, I want you to subscribe, I want you to like, comment, and also share this video so that others can benefit as well. Please do subscribe, do like, do comment, and do share the video. Thank you. To also know that our V, the root mean square voltage, is equal to our peak voltage divided by the square root of 2. While our root mean square current is also the peak current divided by the square root of 2. So now let's look at some examples. Line voltage is 120 volt. Calculate its peak voltage. So here we are looking for peak voltage. So we are given the RMS voltage to be 120. So solution here. So our RMS voltage, as we know, is equal to the peak voltage divided by the square root of 2. Now we are looking for our peak voltage. So our peak voltage will now be what? Our V RMS multiplied by the square root of 2. So our peak voltage will now be our RMS, the V value is this, multiplied by the square root of 2. So that will give us 160.7 volts. So that's our peak voltage. You see, it's higher than the RMS value. So the peak voltage is always higher than the RMS value. Diagram below. So using the diagram below, calculate the RMS current. So from the diagram, you can see the peak current is 30 ampere. This is the current axis in ampere. So the peak here is 30 ampere, positive and negative, 30 ampere. So that's our peak current. So solution, using the diagram below, says you calculate the RMS current. So our RMS current is equal to our peak current divided by the square root of 2. And our peak current from our diagram, it is 30 ampere. And the square root of 2, so divide by the square root of 2. So when you break that down, this is 30. The square root of 2 is 1.414. 1.414. When you press your calculator and you divide that, you are going to have 21.2 ampere. Here we are having another example. Say in an AC circuit, the peak value of the PD is 220 volt. That is the peak value. Your V0 is 220 volt. Say what is the instantaneous voltage when it has reached 1/6 of a circle? So we can use this fraction of a circle to determine our phase angle. So it went 1/6 circle. So to solve this, We are going to use our formula V is equal to peak voltage sine our phase angle. So what is the instantaneous voltage? That is what we are looking for. So our instantaneous voltage is equal to our peak voltage, which is given to us to be 220 volts multiplied by the phase angle, and it's given to us a fraction of the circle. Now, a fraction of a circle of the phase angle, a complete circle is 360 degrees. So for us to look for a fraction, so our phase angle now, let's look for that. Our phase angle now will now be equal to 1/6 multiplied by 360, fraction of that. And when you divide that, that will be 60 degrees. So our phase angle is 60 degrees. So we'll put that there now. We're going to have here, our phase angle now, here will be 60 degrees. So that gives us V is equal to 220 multiplied by our sine 60 degrees, which is 0.8660. So our instantaneous voltage, now when you divide that out, we're going to get 190.5 volts. So our instantaneous voltage is always what? Less than our peak voltage. Please, if you are yet to subscribe, I would like you to please subscribe before we continue. I would like you to like, I would like you to comment, and also share this video so that others can benefit as well. Thank you. So this is another question for us. It says the voltage of a house supply is represented by the equation V is equal to 311 sine 314.2t. Determine the frequency of the AC supply. Determine the frequency of the AC supply. So here, we are going to use our equation V is equal to V naught sine WT. So we're now going to do some comparison. We're going to compare this equation with the equation given to us. We're going to compare this equation with this equation given to us. And let's bring down that equation. We have V is equal to 311 sine 314.2t. So when you will compare, you see V is equal to V. Our peak voltage is equal to 311. So from here, peak voltage is equal to 311 volts. From here, while WT is equal to this. So our WT is equal to this. So WT would now be equal to 314.2t. So from here now, you can see T here, T here, T will cancel out. So we have W is equal to 314.2 radian per second. But from the question we are asked to determine the frequency of the AC supply. The frequency of the AC supply. And we know that W is equal to 2 pi F. So F now will not be equal to W divided by 2 pi. Our W is this, and multiplied by 2, and our pi is 3.142. By the time you press the calculator and you divide this, we are going to have 50 Hz. And please, if you are yet to subscribe once again, please do subscribe, do like, comment, and do share this video so that you can always see every other video we upload. Thank you.